أهلا بكم من جديد، وأتمنى لكم يوم سعيد وموفق بإذن الله. لن أطيل عليكم بالحديث، مباشرة دعونا نذهب للمتحدثون الرئيسيون لثاني أيام أعمال مؤتمر الطاقة الخضراء. باسمكم جميعا دعونا نرحب بالمتحدث الأول تحت عنوان السمات الرئيسية المميزة لأداء المباني منخفضة الكربون، الدكتور يحيي بن عبيد الشامسي، وهو عميد كلية الهندسة والتكنولوجيا بجامعة التقنية والعلوم التطبيقية. الدكتور يحيي الشامسي هو مهندس مدني ومحاضر في قسم الهندسة في جامعة التقنية والعلوم التطبيقية بمسقط، ويشغل حاليا منصب عميد كلية الهندسة والتكنولوجيا في الجامعة. نرحب بالدكتور. السيرة الذاتية تطول للدكتور، وهو المتحدث الأول في ثاني أيام هذا المؤتمر.
Assalamu alaikum wa rahmatullahi wa barakatuh. It's my pleasure today to stand in front of you and present my talk about the key performance attributes of efficient low carbon building. Throughout this presentation, I will try to give a sample of low carbon building and what do we mean by that, and what's the attribute distinguish this kind of building from other or conventional type of building. The presentation will include the motivation, what motivates us to go for this kind of building, and what's the objective of those type of building, and some small introduction and brief introduction about low carbon building, what they are, and how can we distinguish them from other type of building. Then I will go through case study from Sultanate of Oman about exemplar of low carbon building, and how could we implement those features of low carbon building into our residential building. And then I will draw the conclusion and suggestion and recommendation out of my talk at the end of the presentation. One of the drivers for going for low carbon building that the generation of CO2 emissions from our country is high per capita compared to other countries, and that's due to the fact that we are using, I thought everyone is hearing. Is my voice clear now? I hope that. Okay, sorry for the beginning. I will repeat a few of the words that I have mentioned at the beginning. I'm going to present low carbon building here and what distinguishes them from conventional building, and why should we go for this type of building in our construction sector. At the beginning, one of the driver will guide us or make us go to this kind of building is the CO2 emission comes out of the country. It's recorded as one of the top 20 countries in the world. Another drivers to go for low carbon building in the construction industry in Oman, the rate of urbanization. Rate of urbanization in our country is going very high, and we will see that in the next slides. Oman considered one of the top 20 or ranked as 7 in the generation of CO2 emissions per capita. One of the also motivation or drivers lead to this situation is the energy or electricity prices. If we compare the energy and electricity prices in the country compared to some of the industrialized country, we will see a very huge and large difference. And that make the use and consumption of energy in the building not of the top concern of the occupant of the building. And we need to change this habit. Hopefully the recommendation I will draw at the end will orientate in this direction. Looking at the historical background of the country, since 1970, since the year 1975, the emission from the country exceeded the average world emission. And if we look at the trend in the country compared to the world trend, it's increasing very dramatically. And this expected it to go and increase more in the future if there is no action or decision made in different sectors, including the construction sector. The emission, we know all of us, it's very much connected to the rise of the temperature of the Earth, and it has been recorded in the past 120 years that the temperature of the Earth is increasing, and it has been increased by 1 degree, and all the action required is to limit this increase and not to go beyond, because we know that the CO2 residence time in the environment is long. It stays around 100 years, so that means whatever action we are taking now, the results, it may take a long time until it has an effect in our climate. But we need to take the action. To look into the energy consumption in the building, we need to understand the environment in the location of the building. We need to understand the environment, and there are a number of international bodies classify the climate of the countries. One of them is Copenhagen, and it classifies the climate of Sultanate of Oman as arid desert climate. And it is, if we want to go in more details about the climate condition of the country, it's hot, humid in the coastal area, and hot, dry in the interior. And temperature may go up to 50 degrees in the summer, and humidity may go up to 100% in some places and location. And that's very much connected to the amount of energy will be used in the building. This is the temperature, annual temperature in the country, and this is required when we are designing building. If we want to design a building that consumes less energy, and we want to go for low carbon building, then we need to consider 1 full year temperature profile in the location where we are designing the building. Again, this slide shows us the intensity of energy consumption in the countries, and it shows clearly that our country is one of the high intense energy consumer per capita. Now, this is a very quick and brief about the historical and technical background. What I'm going to present from this slide onwards, the scope and the objective of the talk. The scope of this talk is to look into low carbon building from the 5 perspectives. The first one is the design of the building. The second one is the material that the building has been made of, and then the energy use, how the energy used, because we believe that the building by itself, it will not consume energy. The way we use it, it will consume the energy. And then energy performance, how the building is performed in terms of energy consumption, and then carbon footprint of the country, which is important for the reason I have already mentioned in the previous slides. Looking also at the historical background of the construction industry in Oman, in the past, local material have been used, and this local material is climate adapted material. That means it can be used in a such way that it will not require more energy for thermal comfort of the occupant. But the situation has changed in the past 40 years, as I mentioned earlier, due to the urbanization, due to the introduction of new construction material. Basically concrete comes in picture, and most of the building, like the building we are right now in, it's made of concrete. Concrete is a good material for construction, but on the other side, it is not friendly from different perspective. Another issue here, that the total population of Oman, 50% of the total population of Oman, less than 20 years. And that means within 10 years or 15 years from now, more and more residential building will be required. And if we look at the issues have been discussed in the presentation and the talk yesterday, one of the aim of the country is to go 20% green energy. Now, as a percentage, if the demand increase, it will be very hard to achieve this percentage. Therefore, another action need to be taken in order to achieve this target and make it possible to be happen. And the other issue that Oman neutral carbon emission set by His Majesty to be 2050, which is around 25 years from now. And that means not much time, but there is a lot of work need to be done in order to achieve that one. Looking at the construction industry in Oman, for an example, in the city of Muscat, the residential building permits increasing very dramatically. Between 2010 and 2012, 55% of the permit increase within 2 years. That means large number of residential building constructed, and in another way, more energy will be required for residential building suddenly within this short period. If we look at the energy consumption of the building, especially residential building, it's count for 48% of the total electricity consumed in the country. It goes to Oman. Further, if we look at the typology of building preferred by families and in Oman, it's more than 70% villa type or single dwelling, single residential building. Again, this makes the need for effort to be more put in this direction in order to reduce the consumption of energy of those type of building, and also to reduce the emission associated with it. This is the trend of residential permit in the whole country. We can obviously see from this curve, it goes up and down, but the general trend here, it's going up. And as I mentioned earlier, it may go up for the next decade because of the increase of the number of people will require residential building. Looking at this issue from different perspectives, as I said, the energy consumed by residential building account for 48%. On the other hand, the increase of energy need or electricity consumption in the country in the diagram at the bottom of this slide show that the increase of consumption is increasing rapidly. And this is which ring the bell here that if we are aiming to go to 20% green energy, we need really to take an action in this direction. I will jump here just to show you the energy system inside the building. Because of the time concern, I need to accelerate a little bit my presentation, and I have a good experience in doing this, hopefully. The energy consumption in the building, or residential building energy system, consists of two types of energy. The energy comes from outside supply, which comes normally from the grid or from wherever supply comes. And in some cases, the energy provided inside the site of the building. Those two together, they represent the end user or residential building energy system. This system broken down into different subsystems in order to see and investigate where is the more energy consumed, in order, if we want to look or to convert our building into low carbon building, we need to understand those systems. How do they use the energy? The main system here is HVAC, which is more to deal with the comfort inside the building, lighting, hot water, washing and cooking and refrigeration, and home appliance and electronics. The use of those systems is controlled by two factors, one of them physical and the other one is social. Physical factor, obvious, the building type, the building orientation. Social is the occupant behavior, occupant age, and so on. Looking at the breakdown of the energy consumption in those subsystems of the building, we look clearly, as it can be seen here in this slide, that the majority of energy is consumed for HVAC or for thermal comfort. Lighting and hot water comes in the next. And it is interesting that hot water is one of the major consumer of energy in residential building in country in Oman. The thermal comfort is required because of the heat generated or gained inside the building, as we can see here, from different sources, either from external or internal sources. Very interesting, these slides I have drawn from research or study case being conducted by the Authority of Electricity and Power 10 years ago, and it shows us how the cooling system inside a residential building being used by the occupant. For an example, the green color in this slide show you that the space or the room is unoccupied, but the cooling system is turned on. If we look at the green color here and compare it, for an example, to the red color when the cooling off, it's almost the same. So that's an indicator there is a waste of energy inside the building. Now, if we want to go for a residential low carbon building, we need to follow the sustainability approach, which is at the beginning we need to reduce demand, and that the demand reduced through the design of the building. And secondly, use energy efficient appliances, and finally use renewable. So not only using renewable will make our building low energy building or low carbon building. This is one of the old example here in Oman. It is the Majan Electricity Company, one of the first building constructed to be low carbon building, where it's supposed to use a solar panel in the roof, and the design shape being limited through the hexagonal shape of the design. The method normally adopted in comparing or looking at the low carbon building, we need to compare it to residential building. Number of building in one of the study has been compared to 3 best practice or state-of-the-art residential building. Both are compared in order to come up with the energy audit of those type of building. It has been found, similar to what we have seen previously, that the cooling system account for more than 70% of the energy. Interesting that 75% of energy consumed per year in the building happened in 6 months. Half the year we consume 75% due to the energy, due to the cooling system. This is the way how we measure and monitor the energy inside the building. And for monitoring and comparing those two types of building, we need to look into the parameters and main features of both building, like for an example, the envelope or the wall description and windows description, U-value of material, and so on. And then compare those with the energy consumed in the building and check how much is consumed for each subsystem of the building. And this is again comparing different type of building together, because we want to reach to a way where we can compare two type of building in similar condition, because the use of those building is vary. People use the building in different way. We cannot straightforward compare building together to check their energy. The best way to do that is to do analysis or to do modeling, and the modeling has to be conducted in a such way that under similar condition, similar number of hours of use, similar number of occupants, similar age of occupants, and that can be done in number of modeling packages. One of them is IES, which is widely used around the world, and it is adopted by many codes around the world, especially in the Middle East, some of the country in the Middle East. Looking at the comparison between the two type of building, we have at one side two conventional building, and the other side is one of the low carbon building. We can see very clearly that the amount of energy used for thermal comfort inside the building has been reduced dramatically, as well others being reduced. But because this account for the majority, it has dropped down the energy consumption large. The modeling has to be conducted in a such way, as I mentioned earlier, in a such way that both are under similar scenario, and the modeling has to be compared with the measure in order to check that your modeling is done properly, check the peak hours and the time where the maximum energy consumed is similar to the one measured, and then come up with the parametric modeling to see what will happen if we have extracted a number of the features from low carbon building example that we have already constructed in the country, and implement those features or efficiency low measures in the conventional building, and see what will be the effect. The effect, as we can see here, around 58% can be reduced in the energy consumption. And this is very interesting if we are aiming to reduce CO2 emissions from residential building. If we want to reduce the energy consumption of building, Very important that we need to adopt some of those energy measures, energy efficiency measures. So far, there is no rules or regulation force the industry to go for this. Therefore, the energy consumption that we have seen at the beginning of this presentation, the trend will continue going if no action has been taken in this regards. Further, any building need to be labeled like the cars. Nowadays, when we buy our car, we can see the energy consumption of those cars. Similarly, the building have to be labeled in order to spread the awareness of low energy building across the society. This is some of the related international energy codes that used during the design phase of building, and that need to be adopted in any construction industry in order to reduce the energy consumption of those buildings. Further, if we want to change and shift our practice of construction from what the current status is to what we are aiming to, a target performance, we need first of all to evaluate the status like what we have seen in the sample of building have been taken. Then very important that we need to create vision and action plan for the construction industry to ensure that the construction industry of residential building will be changed to the low carbon energy building, low carbon, construction. This can be done through transition period, can be decided by the decision maker in order to make this shift. I will conclude here, very important that when we are doing parametric modeling of building, that there is a results, and these results can be implemented in the work. Suggestion to go for this type of building, there are some barriers before we go for suggestion need to be resolved. For an example, we have seen the climate condition of the country. What things can be done in this? We need codes. We need the climate adaptive design so that the building will not consume more energy than it should. Social barriers. We need to make an awareness for the society. It's very important that people should understand what's the difference between residential low carbon building or green building and conventional building, and how much is the difference is. Because people, they know that there is difference, but maybe they are not visualizing how much is it. We need to have provide motivation for people to move to this. Also provide required legislation, as I mentioned, codes like other countries. I will finish my presentation and talk by number of recommendations that are required in order to shift the industry of residential building to low energy building. Provide country-specific master plan is required so that we know where we are going in terms of managing this industry. Energy efficiency building codes is a must if we want to implement this one. Revise and upgrade the planning regulation for the new development. The approval of condition of the new housing permit has to include the energy efficiency requirements of the design. Establish an energy market. The energy market will definitely help in adopting this type of building. Provide financial support to implement energy reduction measures, the one I have mentioned earlier. It might be at the beginning costly and people may not accept it, the society may not accept it, but so far there is subsidies provided for the energy cost. If this subsidy oriented towards implementing energy efficiency measures in the construction, that will improve the construction industry. Establish energy rating system for the building so that people will deal with the building like when they are dealing with cars. We know how much its energy consume and how much the energy it will consume. Enforce the real estate development to provide energy consumption status of the building so that it will be, the society will be aware about this concept, will be aware about the energy consumption of this type of building, and so on. This is a list of some of the references for those who are interested, and whomever interested in this area of research may contact me directly. I will be more than happy to support and work with whomever willing and looking to work in this direction. This is almost my talk today about low carbon building. I hope that I have presented within this short time something useful for the audience. Thank you for your attention. Thank you.